Just like we did in our last video, let's start by labeling this normal distribution curve with our mean and our standard deviations for the different heights of some adults. Now you'll notice we surveyed, or we measured, or we looked at 1,800 adults. That won't matter for this first part, but we're going to come back and remember that number in a little bit for some questions. So on our normal distribution, I'm going to go ahead and start by labeling the mean, which would be right in the center of your data. And that mean height, that average height, was 70 inches. So we'll label that right there in the center. What I want to do then is I want to make marks for standard deviations, both 3 above and 3 below the mean. So let's go ahead and make 3 marks here. Now we're just estimating, so these aren't super accurate, but it'll help us answer the questions we need to answer. And then I can see from my problem, or my description up here, my standard deviation was 2 inches. And so what we'll do, we'll go ahead and add from our mean. We'll add 2 inches for the first standard deviation, so 72. And then keep adding 2 for each next set of standard deviations. So 72, 74, 76. To go below the mean, then we'll just be subtracting 2, our standard deviation. So we'd have a height of 68 inches, would be 1 standard deviation below the mean, 66 inches, and then 64 inches. And now that we have this graph labeled with mean and standard deviations, we can use the empirical rule to answer some questions. And so first up, we want to figure out how many adults. Now that's important, how many. They're not asking for a percent this time like we did in our last video. They're asking for an actual number from our data. So we're going to go back and use that 1,800 here in just a moment. So first of all though, we wanted to know about how many adults were between 66 and 74 inches. And so going back to look at our graph that we made, I can see that 66 inches and 74 inches represent 2 standard deviations above and below the mean. So looking then at our empirical rule, which I'm sure you have this somewhere in your notes, if I look at the values between 2 standard deviations below and 2 standard deviations above, I can see that that represents a large chunk of my data. In fact, they've already done they've added up all those individual percents to represent 95%. 95% of our population should fall between 2 standard deviations above and below the mean. So let's go back and kind of put all this together then. So I know that 95% of the adults should fall in that range. However, they don't ask me for a percent. They ask me for, of the 1,800 adults we measured or sampled, how many of them would fall into this. So I'm going to take 0.95, that's 95% as a decimal, and multiply that by the 1,800. And so I find out that of the people we measure then, about 1,710 of them should be should have a height between 66 and 74 inches. That would represent 95% of the population there. Okay, and so then one more question down here based on our information. This time again we're asked for probability, so we're back to just percentages this time. What's the probability that we'll find an adult that's more than 72 inches tall? So again, looking back at the graph we made, I can see 72 inches tall represents 1 standard deviation above the mean, and I want to go ahead and be anything greater than that, 72 inches or taller. So we want to find all the percentages that are 1 standard deviation or more above the mean. And so looking back then at our empirical data here, let's get rid of some of those marks, we're not seeing them. We want to be 1 standard deviation, so right there, or more. And so I can see adding up all those individual percentages should get me all the percent that's above 1 standard deviation. So going back here, just jotting down a couple thoughts, we've got 13.5%. And again, I'm just selecting these numbers right here. Probably have those in your notes. So 13.5%. I want to add on that 2.35%. And then finally add on that last one, the 0.15, the very, very small percentage. And I see that the probability that an adult is more than 72 inches tall comes out to be approximately, I always use approximate for these, approximately 16% are going to fall into that category.